solve another Leetcode problem 19. Remove nth node from end of list. So for this problem, definitely there are two ways. So one way is we're going to use the two loops. First of all, we're going to count the total number of nodes. So now, according to the nth node from the end of the linked list, we're going to calculate, how can we count it from the head to the tail. So this is a 2 for loops. So actually, there's a better way to solve such kind of problem. So as n equals to 2 in this example, so we know that, so for example, we're going to count from the end to the start, it's going to be 1, 2, it's going to be this node 4. Actually, there's like a distance of 2. So if this is a pointer, this is another pointer, maybe the distance, so we're going to check that the distance is going to be 2. So what if we find a pointer? What if we find a pointer which is pointed to 3 and another pointer pointed to a none? So if another pointer pointed to none, so we're gonna use this pointer dot next gonna be equal to this pointer dot next. So in this way, we just remove this node 4. But how can we do that? Because we are giving this n equal to 2, this means definitely we can find a distance. Now this is our node. So first of all, we're gonna check a distance. So for I in range n, so we're gonna move the pointer from the head to a distance of 2. So now this is 1, 2, and 3. So it means it's gonna be pointed to 3. So now the pointer pointed to 3, but we can also assign another pointer to the head. But as the distance should be, as this n is equal to 2, but actually while this pointer pointed to the none, so this is none, and another pointer should be pointed to 3, so the distance is going to be 1, 2, 3. So we need to keep a distance of 3, but how can we do that? We can prepare a dummy node. So from the left side, we prepare another node, which is a dummy node. So the dummy node is going to be pointed to 1. So this is a slow pointer, and this is a fast pointer. So here, slow and fast, actually the speed is the same, but the fast just it is after the slow. So now we can move it synchronously, simultaneously. So this one moves to 1, this one moves to 4, and this one moves to 2, this one moves to 5, and the slow pointer moved to 3, and the fast pointer moved to none. So we're gonna stop the while check, and this pointer dot next is gonna be this pointer dot next. So in this way, we just solve it in one loop. Now let's just try to use this kind of idea to solve the problem. So I'm gonna prepare a dummy node, and slow gonna be equal to a list node, and the dummy dot next gonna be equal to the head. Now we're gonna check how many what is the position for the fast pointer. So the head dot head gonna equal to head dot next. So from here, actually we find so from here, this for example equal to 2. So from here, the head gonna equal to head dot next. So this means we're gonna find a position from 1, 2, and 3, and this position gonna be the fast. So fast gonna be equal to this head. Now we can check the fast. So while fast, we're gonna move the slow, gonna be equal to slow dot next, because the slow is just starting from the dummy node, and the fast gonna move as the fast dot next until the fast pointed to none. So the slow dot next gonna equal to slow dot next. By this way, we just delete that node 4, and finally we just need to return dummy dot next. Now let me just run it and submit it to check if it works. As you can see, it works and it's pretty fast, and the time complexity is just O, and it depended on the number of nodes. Thank you for watching. See you next time.